Okay, let's unpack this. Imagine humans crossing vast oceans. Not just thousands, but millions of years ago. It sounds like something straight out of science fiction, right?
Yeah.
But new archaeological findings are pushing back the timeline of early human exploration in, well, incredible ways.
Yeah.
And they've left us with a fantastic, unfolding mystery.
Absolutely. This deep dive is all about a really groundbreaking study. It was published in Nature, led by researchers from Griffith University and Indonesia's National Research and Innovation Agency, BRIN. They've basically uncovered evidence that completely rewrites the story of early hominins. That's us and our extinct ancestors in a really crucial part of the world.
Which part are we talking about?
The Indonesian island of Sulawesi.
Okay, Sulawesi. So for this deep dive, we're digging into your sources, pulling out the most important bits of knowledge for you. Our mission today, explore this, frankly, astonishing discovery in Sulawesi. Figure out how scientists managed to date something so incredibly ancient. And maybe most importantly, grapple with the huge questions it raises about our distant ancestors. Seriously, what they found might just surprise you.
It's pretty remarkable. So this discovery took place at a site called Calio. It's in southern Sulawesi near the Walanae River. And you have to picture this. It's literally a modern cornfield. That's where the team found these things.
A cornfield? Seriously?
Seriously. A field team led by Budianto Hakim from BRIN and Professor Adam Brum from Griffith, they excavated 7 stone artifacts there. It's almost like they were harvesting history alongside the corn. And these weren't just, random river pebbles. They were small, sharp-edged flakes, clearly skillfully struck from larger pebbles.
Okay, 7 stone flakes in a cornfield. And they're talking millions of years ago.
Yeah.
That part. That's what really gets me. How on earth do you date something like that with that kind of precision?
Right. The scientific detective work here is truly fascinating. They use 2 main methods. First, paleomagnetic dating. That's looking at the sandstone layers the tools were actually found in.
Paleomagnetic, like Earth's magnetic field.
Exactly. It uses the Earth's ancient magnetic field reversals, when North and South poles literally swapped places. These events are like global geological timestamps, really well documented. So they let scientists date the layers of Earth pretty accurately. And their findings showed the artifact layers were older than about 773,000 years. That's a known boundary, the Brunnes-Maruyama boundary.
Okay, so over 750,000 years just based on the Earth layers. That's already way back.
Yeah.
How does that earlier date for Sulawesi stack up against, other early human sites globally?
Well, it definitely puts Sulawesi on the map much earlier than previously thought, aligning it more with some of the really early known movements out of Africa. But they didn't stop there. They also used a direct dating method. It's called uranium series and electron spin resonance, or USESR. Bit of a mouthful.
USESR. Okay. What do they use that on?
On a fossil. A Celebocarus pig fossil, to be precise.
A pig?
Yeah, a pig. This technique basically measures the buildup of radiation damage over time in things like tooth enamel. It gives a direct age for the fossil itself. And this specific fossil was really important because of where they found it. It was excavated from a layer just above the deepest artifact.
Ah, okay. So the pig fossil gives you a solid age, and because the tools were below it.
Exactly. That fossil provides a minimum age for the tools underneath. The USESR analysis gave a likely age for the pig fossil of 1.26 million years, give or take about 0.22 million years.
Wow. So that means the tools have to be older than roughly 1.04 million years.
Precisely. At least 1.04 million years old, and possibly as old as 1.48 million years.
Just to try to wrap your head around that. Over 1 million years ago.
It's almost impossible to truly grasp that time scale, isn't it? And this is just a massive leap. The previous oldest evidence on Sulawesi, from a site called Talapu, was only dated to about 194,000 years ago.
So we're talking hundreds of thousands, maybe even over 1 million years earlier than we knew hominins were there. That's incredible.
It really is.
And it's not just the age, right? It's what it implies about how they got there. This wasn't just a walk across land bridges, was it?
No, not at all. This journey meant overcoming a huge geographical challenge.
The Wallace Line.
The Wallace Line. Right, I've heard of that. It's like an invisible barrier in the ocean. That's a good way to put it. It's this deep water channel running through the Indonesian archipelago. It's such a formidable marine barrier that it separates entirely different sets of animal species on either side. Think kangaroos on one side, tigers on the other, that kind of difference. Professor Brum actually highlighted this. He said, This discovery adds to our understanding of the movement of extinct humans across the Wallace Line, a transitional zone beyond which unique and often quite peculiar animal species evolved in isolation. Crossing it means crossing significant stretches of open ocean.
Which was thought to be impossible for such early hominins for a long time.
For a very long time, yes. The oldest really clear evidence before this for crossing deep sea barriers was on the island of Flores at a site called Walanae. That dated to around 1.02 million years ago. And that's where they eventually found Homo floresiensis, the hobbit.
Ah, the hobbits of Flores. So the idea there was maybe Homo erectus crossed over and then evolved into the smaller form, island dwarfism.
That's the leading hypothesis, yes. Homo erectus somehow makes the crossing, gets isolated on Flores, and undergoes island dwarfism.
But now Sulawesi. This finding puts toolmakers there potentially even earlier than the Flores evidence.
Yeah.
Or at least contemporary.
Exactly. It puts Sulawesi right in the same time frame, maybe even pushing it back further. It really challenges the idea that Flores was some unique, isolated case of early deep-sea crossing.
Okay, so they made this incredible journey. What about the tools themselves? What did those 7 flakes tell us about these ancient travelers?
Well, the analysis showed quite a bit about their capabilities. They were made using a technique called hard hammer freehand percussion. Basically hitting one stone, the core, with another harder stone, the hammer stone, to knock off shark flakes. Simple, but effective. And these flakes showed evidence of a 2-step reduction process.
Okay, what's that?
It means they weren't just bashing rocks randomly. They likely knocked off larger primary flakes first, and then perhaps refined those or struck smaller, more specialized flakes from the core. It shows planning. The researchers noted, and I quote, "expert technical knowledge within the context of a straightforward, least-effort approach to toolmaking."
So, skilled, but practical. Not overly fancy, but they knew what they were doing.
Precisely. And another key thing, the flakes were statistically larger than the natural pebbles found in the same layers.
Which helps prove they didn't just wash in there or break naturally.
Exactly. It strongly supports that they are anthropogenic, made by hominins. The thinking is they probably made these tools elsewhere, maybe closer to a river source with good pebbles, and then carried the finished flakes to the Calio site to use them, perhaps for butchering animals or processing plants.
Okay, so definitely skilled tool makers making deliberate sea crossings over 1 million years ago. Incredible evidence. But there's still a big but, isn't there? What's the catch? What are we still missing?
The biggest question mark, and Professor Brum stated this quite clearly, is who were they? He said, it's a significant piece of the puzzle, but the Calio site has yet to yield any hominin fossils. So while we now know there were tool makers on Sulawesi 1 million years ago, their identity remains a mystery.
No bones.
No bones, no skulls, no teeth, nothing identifiable yet. So we don't know which species of hominin made this incredible journey and these tools.
Could it have been Homo erectus, like the ancestor proposed for the Flores hobbits?
That's certainly a possibility. Homo erectus was around at that time and known to be adaptable, but it could also have been some other group, some early human relative we haven't identified yet in this region, perhaps one uniquely adapted to this island environment. We just don't know.
Right, so let's just recap where we are. We've taken this deep dive into your sources about Sulawesi, and they reveal stone tool-making hominins were definitely there at least 1.04 million years ago, maybe even earlier, up to 1.48 million years ago, which is just hundreds of thousands of years before we thought. And we see how this completely challenges our old ideas about early humans crossing deep oceans, specifically the Wallace Line.
What's really fascinating here is just the sheer audacity, the resourcefulness of these early hominins, crossing ocean barriers we used to think were insurmountable back then. And the Calio site, even with just those 7 flakes, it shows sophisticated tool-making ability over 1 million years ago. They knew what they were doing. But yeah, the most intriguing part, as Professor Brum pointed out, is that mystery. Despite the tools, who were these ancient mariners? We have no idea.
And that leaves us wondering about Sulawesi itself, doesn't it?
It does. Sulawesi is huge compared to Flores. It's apparently 12 times the size, ecologically really rich. Professor Brum called it a mini continent in itself. So if Flores could produce the unique hobbits, what evolutionary stories might be hidden on an island as vast and complex as Sulawesi?
Could there be other unique hominin forms there?
It raises that exact question. What kind of hominin was resourceful enough to make that journey in the first place? And then, isolated on this massive island for potentially 1 million years, what unique evolutionary paths might they have taken? It's wide open.
And this is where it gets really interesting for you, the listener, to think about. If these hominins reached Sulawesi over 1 million years ago, and if they were potentially cut off on this massive wildcard island for such an incredibly long time, what does that tell us about the adaptability, the sheer resilience of our ancient ancestors? It's kind of mind-boggling. And it makes you wonder what other hidden chapters of human history might still be buried out there, just waiting to be discovered. Keep thinking about that. Because this deep dive, it's really just the beginning of the journey into our deep past.
Yeah.